This will be a practice test of chapters 9 and 12. And again, suggest you write the example down and then what steps to solve it. So let's write it big here. 5y squared equals 50. Now here they want you to use the square root property. So you want to try to get y squared by itself. So I'm going to divide both sides by 5. And I get then y squared equals 10. And then the protocol to do it is you take the square root of one side and then plus or minus the square root of the other side. And you get y then equals plus or minus the square root of 10. So that's pretty straightforward. And they wanted you to put it this way, or if they give you the choice of the combination signs, you can use that. Now in this next one, again, take a moment to write it down. And again, they want you to use the square root property. So I'm going to divide both sides by 3. And I get x squared now, after these cancel out, equals 20. Now take the square root of this side, plus or minus the square root of that side, and you get x equals plus or minus the square root of 20. Now if you put that there, they're going to count it wrong because you didn't simplify the radical form. So let's take a look at that. The square root of 20 is actually the square root of 4 times the square root of 5. The square root of 4 is 2, the square root of 5. So your answer then is going to be x equals plus or minus 2, the square root of 5. You've met all the requirements of what they're asking. Now, for a word problem like this, the first thing you have to do is read the problem carefully. An arrow is shot vertically upward from a platform 31 feet high. So there's my platform. I'm standing on top, 31 feet from the ground. I'm going to shoot an arrow, and then eventually the arrow is going to fall to the ground. Now I have an initial velocity of this. When will the arrow hit the ground? So this is in seconds, and we use this formula. They want you to round to the nearest tenth. So I've copied the formula, and my height is going to be 0. I want it to reach the ground. So I have a negative 16 t squared. Again, I don't know what t is. Now my initial velocity, that is v sub o, is going to be 220. There's a t there as well. And when will it hit the ground? And our height initially when we shoot it is going to be 31 feet. So I have successfully substituted into my equation. Now keep in mind we can also take this negative and multiply through by a -1. That would change all the signs and make my calculation a little easier. So I'm going to multiply everything by a -1 here. So now this still stays 0. This becomes 16 t squared. This now becomes a negative 220 t, and this becomes a negative 31. All right, so I just changed the signs by multiplying everything by a -1. Now, this might be able to be factored, but it looks a little daunting, so I'm just going to put this into the quadratic formula, and you should try it as well. So let's take a look at this. So our B value is a negative 220, and the formula is negative B. So the opposite of a negative 220 is a positive 220. Now, I have here plus or minus, but we're probably not going to use the negative. So we're just going to look for the positive value. Now, there's my B that I'm squaring. And then negative 4 times A, which we said was a positive 16, times my C term, which is a negative 30. So I'm going to put all of this into my calculator and then round it to one decimal place. All right, let's see what we get. Now, when I put all of that into my calculator, my positive value is 13.889. I have to round to one decimal place, so I look at the hundredths place, 8. So I'm going to drop this and make this 8 13.9, and that's what it is. Now again, part of it is understanding the example. A sketch would be helpful. Getting rid of the negative up here, carefully putting it into the quadratic formula, and then rounding correctly. Again, take a moment to write the example down. Now, this is a fractional exponent. We said the 1/2 power of anything is the square root of 1/9. And we could take that as the square root of 1 over the square root of 9. Square root of 1 is 1. Square root of 9 is 3. So our answer is 1/3. So we're going to have some easy ones, I guess. So here we're asked to solve this using the quadratic formula, where we have to identify the A term, which is the 6, the B term, which is a negative 5, and the C term, which is a negative 3. And this was done correctly. Now recall, it has to be in standard form to properly identify the A, B, and C term. They're giving you the quadratic formula. They want you to substitute. Notice somewhere in these slides they will give you the quadratic formula, so you perhaps should write that down on your paper somewhere. You needed that for an earlier example. So we're going to get x equals a negative b. Well, b is a negative 5, so a negative b would be a positive 5, plus or minus the square root of b squared, which is 25, minus 4. A is going to be 6, and C is a negative 3, and that's all over 2A, which is 2 times 6, which is 12. So now you have to do your calculation and then see what you get for an answer, and keep in mind you need to simplify if possible. So when I multiplied a negative times a negative, this became a positive that I added to 25, and I got 97. And I looked at that for a few moments and saw that there was no factoring, that there's no perfect square in there. So this is the answer. Now again, if you have something like this on your blue sheet and you didn't simplify this radical, they would count it wrong, but I would give you partial credit. Let's go on. So again, take time, pause it, read it, and see if you can visualize what's going on here. And then maybe with a picture or something, develop an equation. So something like this. Here's the auditorium, and these are the number of rows in the auditorium. We don't know how many they are. We're going to say it's X. But here it tells us the number of seats in each row exceeds the number of rows, which we said was X, by 13. So X plus 13 is the number of seats in each row. So we're going to distribute that, get X squared plus 13 X. Transpose this to the other side to put it in standard form, and this equals 0. Now here you have to decide, do you want to try to factor that? Because this will factor, or put it into the quadratic formula. I'm going to factor it, but you can try the quadratic formula. Remember, you want to get an answer. And since it's number of rows and seats, it's going to be whole numbers. So you don't have to worry about radical numbers here. So I'm going back to chapter 7 here for my factoring skills. So there's my number. I can take a 2 out of all of these, and then I end up with 53, and I can't take anything out of there. So I go 2 times 2 times 2 is 8 times 5 is 40. So the product of all of these is 40. 40 times 53 is 2,120. And the difference between these two is 13. So this one wasn't bad at all. So it's going to be 53 and 40. Now I need a positive in the middle. So this will be positive for my outers. This will be negative for my inners. So when I solve this, I get X. Remember, equate each of the factors to 0. X equals 40, or X equals a negative 53. Well, you can't have a negative 53 as a counting number or number of rows. So the number of rows is 40. Now, if you were to put 40 here, of course, that's wrong, because we said 40 was the number of rows. That's where you need to understand what they're asking and answer the question that they're asking. So 40 plus 13 is 53. That's the number of seats. And that was correct. Now, as we move on to example 7, here's a quadratic equation in standard form. They want us to identify the A, which is 1, the B, which is 7, and the C, which is negative 2. Now they want us to use the quadratic formula to get answers, because this is not factorable. They give us the quadratic equation. So take a moment to do your substitution. Pause. Now that you've done the substitution, this one you probably can do in your head. So negative times negative will make this a positive here. So this is a positive 8, and a positive 49 gives you the square root of 57 here under the radical sign. It's going to be plus or minus negative 7. And then that's all over 2. So pretty straightforward. And they wanted you to write that, again, clicking the bubble here, 2 different real solutions. and then writing them separately. So again, you have to follow what they're asking. And I told you about blue sheets and partial credit already. And in this example, again, they wanted you to look at the discriminant, which is what is under the radical sign, and seeing that you got values greater than 0, you had two different real solutions. And then we did that part already. So again, write it down. This is kind of an easy one. You want to put two radical signs, and then think of factors of 24, the largest perfect square factor under one radical sign, which is 4, and then whatever's left over under the other radical sign. 4 times 6 is 24, but now we know the square root of 4 is 2, the square root of 6. So a rather easy one that might be used as part of a quadratic formula where you had to simplify this radical. Now for this one, they're asking you to put this quadratic equation in standard form. So I would just take my negative y squared, transpose it to the other side, and get y squared minus 22y plus 121. Now it's in standard form. I can identify my a term as 1. My b term is a negative 22, and my c term is a positive this. Now you'll notice these are all opposite signs. Well, because instead of taking this to this side, they took everything from this side and moved it to this side. So that would be correct as well. But having them with the, remember we said we wanted to have our a term positive if we can. The answers come out the same. Now, if you had these other values down here, let me just erase this now, and put it in the quadratic formula, it'd come out the same. But I look at this and I see that this is actually a perfect square trinomial that will factor into y 11, 11 minus minus equals 0. And since they're both the same, I only need to solve one of them, and I get y equals 11, which is the answer. But again, they wanted you to use the discriminant to determine how many solutions would you get. Well, when you put this and substitute the values, you get that under the radical sign, it's a 0. So it's going to be plus or minus 0, so you only get one answer, and that's what they were looking for here. But you actually got two, but they were the same. So in a sense, one answer, and that was 11, and there was the solution. Again, you have to study, check things out, understand what they're asking. Now, as you do this last one, here the equation is in standard form, so you should have a protocol on how to do it. This doesn't factor, so you would have to identify your A term, your B term, and your C term once it's in standard form. So our A is 7, our B is a negative 3, and our C is a negative 2. So again, somewhere you had the quadratic formula written. Now a negative B will make this a positive 3, plus or minus the square root of b squared is going to be 9, minus 4. A is 7. C is a negative 2. And all of this is going to be over 2 times A, which is 14. So we'll give you a moment to figure this out and see what you get. So as we do the calculation, a negative times a negative here will give you a positive. So 4 times 2 is 8. 8 times 7 is 56, plus 9 is 65. Now, again, you're going to be wondering, can 65 be factored into simpler forms? Well, you can get a 13 times 5, which are the factors of this, and neither one's a perfect square. So you leave it this way, and they do want you to write separate answers. So be careful as to what they're asking. Separate multiple answers, separate multiple answers with commas. So they didn't want this form. But again, if you put that in there and they marked it wrong, I would jump in and give you credit. Okay, well, not too long, but again, I paused it frequently to do work as you would. You want to be sure you know how to do these examples. What is the question they're asking, and are you sure to answer the questions? All right, we'll wrap this up just a little over 20, well, just 22 minutes.